Hmm,
Who
Thank
is
you.
this? Is the lecture already in or what? Who is sharing the screen? Hey, that was quick.
I've been
Someone.
here. I've been here listening. I've been here listening to you. So you're welcome. Okay. Hello and good morning. I hope you can hear me.
monitor.
Yes, sir. I
Okay,
can hear you.
thank you. So today we want to look at logarithm and exponents. I hope last week interaction was meaningful and also helpful to all of you who were able to come. And I hope we will be able to do that one more time before you write your exam. So let's see how best we can be able to equip ourselves with all these things that we are being taught. Okay, so like I normally do, I want you to have an idea of what these functions are for, what they are used for, and what are some of the applications which you see. So we started with algebraic expressions and we went to linear equations, went to polynomials. There's one function known as rational. I'm jumping that, not because it's not important, but with respect to what you'll be examining in exam, that may come as a mid-semester questions or an MCQ. It will not come in the final exam. So I'll try and solve some questions of that later. But I just typed this in Google to give you a cursory look at what logarithm functions can be used for, because there's quite a lot of laws here. So here, we see here that it is used to analyze algorithm. That's one of the first things we are able to use log functions and exponents to do. Number two, be able to manage data structures. And then number three, how to model growth, systems of growth. So if you check any of our investment models, like treasury bills and all these investment models with our banks, most of them are using either like logarithm or exponential functions to be able that this topic or this subject can help you have a better understanding of what you can do in information technology and also in computer science. Some other examples that can help us understand. So far as you're concerned is you'll be given 2 questions in MCQs and 1 question in session B that you can choose from. Okay, so it's a topic that name is this. I'll repeat it at the end of the class again so that those who may join later can be able to do it. Okay, so let's see. I have a PowerPoint on exponents, logarithm and exponent, but I'll just show you briefly what that PowerPoint is. But I'm going to use an Excel document to explain what I want to teach you this. So these are the things we'll be looking at: the rules of exponents and the rules of algorithm. And then we'll see what a natural log looks like. And then we'll look at some of the relationship between log and exponential functions. And then basically some application. Now, the last slide here gives you the applications to logarithm. This is modeling with mathematics, skydiving, the equipment that are used to determine the altitude and the pressure of those who do skydiving, or those who are involved in those type of games, or their life and their work depends on this, all depends on functions like this. Okay, so basically this is what we'll be looking at today. Now let's start with the laws. With the laws of. So I have arranged all the laws systematically, one after the other, to the end. I'll drop this file again with you when I'm done. So this file, this document is designed in such a way that after the law, I have a question. After the law, we have a question. So let's go through the first 10 of them. And like I told you, if you take your past questions, the formulas are the back of the questions. So there's no need to memorize these formulas. You only need to understand how they are used. Okay, so let's brace ourselves with how these laws are used. Okay, so in logarithm, the first most important formula is addition formula. Now, this addition formula, what it does is that when you have two logs that are being multiplied, it means that you can sum the individual logs. So log x times y can be written as log x plus log y. So this is a summation rule. When you're given the problem, you must be able to tell if the left-hand side is a product of two numbers, then you can break them down into the sum of those numbers. Now, its exponential component is that when you have a number a raised to the power p times another number a raised to the power q, again, it means that you will sum the powers. So multiplication again in exponents, two bases with different powers, when they are multiplying, can be added on the right-hand side. So multiplication goes with addition. Then the subtraction rule, it says that when you have a log of a number divided by another number, then that log can be subtracted from each other. Log x divided by y becomes log x minus log y. Okay? Now, when you have a number raised to the power p, all divided by the same number raised to the power q, then from the exponent rule or the quotient rule, you subtract the powers of these bases. So a raised to the power p divided by a raised to the power q becomes a raised to the power p minus q. Then the third rule. The third rule says that when you have a log of a number, all raised to a power, log x raised to the power n, can be written as the power n now comes to multiply the log of x. We call this a power rule. Log x raised to the power n becomes n log x. And then in the form of exponent, a raised to the power b or raised to the power c becomes a raised to the power b times c. Okay, so these are the three basic rules. And there are some rules, there are rules that almost always all the way up to rule number 10. They are some rules that you need to be familiar with, but we don't necessarily always see them in questions. So the first one is number 4. How do you change the base of a log? Okay. Not necessarily my question. Maybe when you are solving questions, you may come across something like this: change of base. Log x to base a can be written as log x to base c, and then log a to base c. It means that you are changing the log of x of base a, this a, we are changing all to base c. So this is a property that you need to use. Then we have the equality property. This equality property, what it does is that when you claim that two logs are equal, if you say log a is equal to b, and then log c is also to base b. If that observation is correct, then you can comfortably say that the number a must be equal to the number c. So this is how we verify that two logs are equal. The bases must be the same. Then you can equate the numbers. Okay, rule number 6. Anytime you evaluate a log and it's equal to 1, it's equal to 0, then that log must be equal to 1. So log 1 is always 0. Log 1 is always 0. Log 10 is always 1. So when you evaluate the log of a number, you get 0, that log must be 1. And when you evaluate a log that is equal to 1, then that log must be the log of a number to the same base. Log a base a is 1. Log b base b is 1. Log 10 base 10 is 1. All these functions are applicable on the family of logs. Okay, Now, rule number 8, please, let's jump over 8. Is just take a look at it. It comes in when you are solving a problem. But let's look at 9 and 10 and 11. Rule number 9 is just an observation. Number 9 says that log x, any log function you see is actually log to base 10. So when you open your calculator, you will see that those functions that you have to apply log automatically. The calculator has written them in base 10. So some calculators will write log, others will write lg. So log of a number is actually to base 10. Then log of a number to base e on the calculator is written as natural log, ln. Okay, natural log. I don't know whether you are familiar with these things on your calculator. Okay, so see whether I can see the calculator. I hope you can see the calculator on your screen. So what I'm saying is that the log of a function, this log that we are seeing here, this log of a function is this thing that we are seeing here. So when I say log, for example, log 10, okay? When I close the brackets, you see that it will give me 1 because this log you see on the screen is log to base 10. So log 10 base 10 is actually comparing what we have here, log of the same number to the same base. This, I think, property 6, property 7. When you have log of a number to the same base is equal to 1. So why is log 10 equal to 1? Because this is log 10 to base 10. Okay, so take note of some of these things that we have on the calculator. And then I said natural log, the natural log of a function, and the natural log of a function is known as ln, ln. It's known as ln. So this function you see here, ln, is known as the natural log. Now, natural log is also shown on your calculator after the log function. So again, if I type in log, natural log of 10, and you ask the calculator to evaluate, it will give you a decimal because this log 10 to base e. The natural log is actually the normal log to base e. Okay, so this is how these calculators represent these two functions. This is log, and this is natural log. Okay, this is log function, and then this is the natural log function. They are all on the calculator. Okay, so now let's take some practice questions. This rule you have here, log a, log x to base a is equal to y. This part of the rule, we can change it to exponents. So sometimes the question will say, change log to exponential form or change from exponential form to log. How do we do that? Okay, to do that, we are going to apply this rule. So we are going to start our questions with this particular rule. When you have a log of a function, how do you change the log of a function to exponential expression and vice versa? So let's try these examples here. Okay, So looking at what we have here, what will be log 16 base 4 equals to 2? If I want to change to exponential function, can somebody tell me how to change to exponential function? Anyone?
Hello, sir.
Yes, please.
It will be 6 4 raised to the power 2.
Okay, so 16 can be written as, 16 can be written as the base 4, okay, to the power 2, okay? So when you have log of 16 base 4 to equals to 2, changing to indices, then this 16 becomes 4 raised to the power 2. Okay. Let's try another one. And somebody else try this for me. Log 81 base 3 is equal to 4. So changing it to exponent, what would this be equal to?
That will be 81 equals 3 raised to the power 4.
Three raised to the power 4. Thank you. Okay, a little bit more interesting. Number 6. Log 9 base x plus 1 is equal to 2. Log 9 base x plus 1 is equal to 2. How do you change it to exponent?
It will be 9 equals to x plus 1 raised to the power 2.
Okay, so x plus 1
Raised to
or
the
raised
power
to the
2.
power 2. And I hope you know that this can be expanded. This will give you x squared. Then this will give you plus 2x or plus 1. Okay, so if you're asked to solve, you can be able to bring the 9, you can bring the 9 to the right-hand side. And that expression, if the question says simplify, then your answer will be the x squared plus 2x. And then if 9 goes to the right-hand side, it becomes minus 9. So minus 9 plus 1 will give you minus 8. And then you equate it to 0. Okay, equate it to 0. And then you have your quadratic equation as this. Okay, then you come to your calculator, you press mode, you press equation, you press quadratic 3, you put the coefficient there, x squared, the coefficient is 1. X term, the coefficient is 2. And then the constant term, the coefficient is minus 8. You press equal to x1. So you say that x1 is equal to 2 and x2 is equal to minus 4. So you are realizing that we can be asked to simplify expressions like this if you are changing from log to exponents. Okay, so I hope everybody can be able to change from log to exponent. Or do you? Is everybody okay? Can I assume everybody can change from log to exponents?
No, sir.
Log
Please.
Please go over one more time, please.
Okay, so the ones we've left out, let's do it. So log 10 base 100 is equal to half. Log 10 base 100 is equal to half. Changing it to exponential form means that the number 10 should be equal to the number 100, which is a base raised to the power half. Please, what is any number raised to the power half? What does it mean? Is it not square root?
Yes.
Square root.
Square root. And you know that square root of 100 is 10. Okay, so this is how we change from this log exponential to exponential function. Again, number 4, we have log of 4 base a is equal to 3. So we want to change it to exponential function. And that will give us 4 is equal to a raised to the power 3. Okay, it means that if you want to solve for a, you must find cube root of 4. If they ask you to solve for a, then you come here. What is cube root? So cube root is 1 over 3. I have to clear this. Shift 9, 3 is equal to AC. Okay, so cube root is 4, the number 4 raised to the power 1 over 3. So 1 divided by, and that will give you 1 point something, something, something. Okay. Again, maybe one more. What about number 5? How do you change this to exponential form? I need to hear a lady's voice. Or anyone who can volunteer to change this for us. Log 2 base E is equal to 0.6931.
Hello, sir.
Yes,
Please. 2 is equal to
Okay.
E raised to the power 0.6931.
Okay, so E raised to the power 0.6931. Okay, so I hope you know how to key these things on the calculator. This is E. E is shift of natural log. Okay, then you enter 0.6931. You see that the answer will be approximately equal to 2. It's 1.9. Part of our example is taking your time, and always, please, if you've forgotten, just go back to the rule. If you want to change from log to exponent, x log x base a is equal to y, then the x will be equal to the base a raised to the power y. Okay, Nathaniel, you are my namesake. What's your question, please?
Please, does it always need to be simplified, or you just leave it at that state?
Oh, it's just because I want to show you these functions on the calculator. If you are supposed to simplify it, you'll be told.
All right.
By the time we are ending, you will see questions that will tell you evaluate or simplify. Those ones, then we have to go beyond just leaving them in the forms of exponents.
All right.
Okay, so now we want to now do the reverse. This time we have been given the exponential function. 5 squared is equal to 25. Okay, 5 squared is equal to 25. So if you look at the formula on the top, it means that a squared, a raised to the power y, is on my left, and then x is on my right. And please look at the formula. If it is x, then it must be log x to base a is equal to the power y. So who can help us with 5 squared is equal to 25? This should be log of what to base what is equal to what? Any volunteer?
Yeah. Perfect.
Okay.
Angela, I want to try again.
Yes, please. So this is equal to log 25 base, I think is base 2 equal to 5.
Okay, so that means, I didn't hear the first part. That means log 25.
25
Yes, base 2
base 2 equals to 5.
is equal to 5. Exactly.
Yes.
Exactly. That's it. Okay, so now you always will concentrate on the answer. That will be the log of the answer to the base of the exponent, and the answer will be equal to the power. Okay, I'm repeating again. You should always log of the answer to the base of the exponential function, and the answer will be equal to the power. Okay, so yes,
isn't
please.
the log supposed to be log 5, 25 raised to the equal to 2?
Yes.
Log what? Log what?
Log
Again,
5.
please.
Log 5, 25 raised to the power 2. Hey, sorry, equals to 2.
No, it's not log 5. It rather should be log 25. Please look at the formula at the top. Okay, x is
So
equal to ay.
I'm saying the place you have written the 2, isn't it supposed to be 5?
Oh, okay. You mean my answer?
Yes.
Yes, you are right. Yes, you are right. Sorry. Yes, you are right. Base 5 is equal to 2. The answer should always be equal to the power. Okay, the answer should always be equal to the power. Please look at it. So x here is my log of x. And then the a here is the base. So here, my a happens to be the 5. So that means log 25 base 5. And the answer is always equal to 2. And please, even when you are very sure of what you are doing, you will realize that if you expand this, what is log of, what is 20? You understand my question?
The line was breaking, so we didn't hear.
I'm asking that I want you to change 25, the number 25, in terms of 5. It is 5 raised to the power what?
5.
5 to the power
5,
2.
5 raised to
5
the power
2.
2. So, exactly. So this can be written as 5 raised to the power 2. I'm just trying to explain so that you can see that the answer we got is correct. And to base 5. Okay. And you know that this can be written as 2 using the power rule. This can be written as 2 log of 5 base 5. Okay. On what we learned, I think formula 7. Log to the same base is equal to what? Log 5 to base 5. This thing, what will it be equal to?
1.
1.
1.
1.
Okay,
1.
so you see why this answer is equal to 2, because it becomes 2 times 1. Okay, 2 times 1, and the answer will be equal to 2. So this is why the expression you have here, log 25 base 5, is equal to 2. This is the original question. So that is why this answer is equal to 2. If you take your time and expand, you can verify that this is actually right. Okay. Okay, so let's try another one. Logarithm. So this should be log of what? Again, another volunteer.
Log 1 base 4 is equal to 0.
Log 1 base 4 is equal to 0. Exactly so. Okay, so always the right-hand side to the base of the left-hand side is equal to the power. Okay, let's try one more, and then we'll move on to the next property. So 7 raised to the power -1 is equal to 1 over 7. So what should this log be equal to? Log what?
Log 1 over
Log
7
Log 1 over 7.
base
Okay.
7
Base 7
is equal to
equals
base
-1.
7. Okay, it's equal to -1. And you know that 1 over 7 can be written as 7 raised to the power -1. Okay, this 1 over 7 can be written as 7 raised to the power -1. And the -1 comes to multiply using the power rule, and you get this answer in here. Okay, so I'll share this file so that you can finish up. I have quite a few more. The same, maybe I should do the last one. This should be log 5. Log 5 to base 8. Base 8 is equal to the answer x. Okay, now the next two rules are going to be very, very simple. We call it the cancellation property. Log of a number to the same base, but the number is raised to the power x. The answer is always equal to the power x. This particular example, if you take your time, you can verify that this thing you see here, this log a raised to the power x base a, can be written as x times log a base a. Okay, if you use the power rule. So if x multiplies the log a to base a will be equal to 1, and 1 multiplies x. So that is why when you have log of a number raised to a certain power to the same base of the number, the answer is always the power. Okay. Then in the exponential form, if I have a number, but that number is raised to an exponent of log of a number to the same base of the number, the answer is always equal to x. Let's just take a cursory look at these two formulas, okay? And then tell me, what will this based on what I've just showed you? What should this be equal to?
3.
Equal to
3.
3.
3.
Equal to 3, isn't it? Equal to
Yes,
3.
please.
That should be your answer. Basically, it's equal to 3. The second one, 10 raised to the power log of 14 base 10. This should be equal to what?
14.
Equal our log of x base 5. This should be equal to what?
X.
X.
Okay, x. Okay, so these are that cancellation. Daniel, your hand is up. What's your question?
So please come again.
The rule on the right. We're saying that if I have a number, this number a, raised to the power log of a number, another number, but to the same base as the base of the number I began with, the answer is always equal to x. Okay? So a raised to the power log of x base a, the answer is x. So when we came here, we said 9 raised to the power log of 3 base 9. You see that this base of this log is the same as base of the indices or the exponents. If this happens, the answer is always equal to the log of the number that the log is you are evaluating. So 9 log 3 base 9, the answer is 3. Immediately you can verify that the base of the log is the same base of the original question, and the answer is always equal to the number of the log. So that is the property we are using to solve this. So 5 log x base 5. You see that the base 5 here is the same as the base of the original question. So the answer is always equal to the log of the number given, log x. So the answer is equal to x. Okay, so Daniel, I hope you're okay now.
Yes, sir.
Okay, now let's take the log part. This time, it is not a number raised to a certain power. This time, log of 15 squared to base 15. If you look at the power rule, you can see the answer immediately. What will this be equal to?
2.
2, exactly. The power rule will make 2 log 15 base 15. That will give you 2. And then log of the number 10 raised to the power negative 8 is equal to base 10. It should be equal to negative 8.
Minus 8, negative 8.
Exactly. Okay. So the property makes the work easier. If you can remember the property, you can be able to give the correct answer. Okay, so I'm sure that this one you can tell log e raised to the power x base e should be equal to x. Okay. So now let's take the same cancellation rule, but this time for natural log. Please, I told you that the natural log is written as ln lane. That's the name for it, natural log. And this natural log here, please, I explained that this ln is stand for log to base e. A log of a number to the same base automatically becomes 1. Ima, your hand is up. Ima Sechi.
Yes, sir, please, your network is worrying a little. Can you please go over what we just started? Your network is breaking.
Okay. Sorry. MTN is disappointing today. Okay, here. is actually log of a number. Let's say that log of a number to base e. Okay, I haven't written the equation editor. So this is what it means. When you say ln, it means log to base e. So when I say ln of x, it means that log e to base e. Log e to base e. And log e to base e will give you 1. So if I say natural log of e raised to the power x, the answer is always equal to x. Okay? I hope you remember this. Natural log of e to any power, the answer is equal to the power. And if I have e rather raised to the natural log of x, the answer is always equal to x. And then using log of 10. Log 10, you know that the log on the calculator is log 10. If you have log 10 raised to the power, then the answer is always equal to the power. Okay, so let's see what happens here. What is natural log of e?
5.
It's 5.
5.
It's 5.
Raised to the power 5. What should the answer be? The answer should be equal to
5.
Should be equal to 5. Okay. And then 10 log 10 raised to the power square root of x. What should your answer be equal to?
Square root of
X.
So square root of x, or x raised to the power x raised to
X raised to the power 1
I
over
think 1 over 2, and
1
1
over
over 2.
2.
Okay. Okay, so it's just square root of x. I'm trying to write this the way we will see this in an indices form. Okay, square root of x is x raised to the power half, or just put it here, square root of x here. That should be your answer. Okay, now what about 10 raised to the power log 9? 10 raised to the power log 9. The answer should be equal to what?
9.
9.
9, sir.
Okay, so this should be equal to 9. Okay, now e raised to the power natural log of 6. This should be equal to
6.
X.
Okay. Okay, so today we've looked at all the laws that is necessary. We looked at the cancellation property. Now the rest of the time we want to take questions that will look like an exam question. So that's what I want to do till we end. So these questions, practice questions, when I finish, I'm going to show you the last year past question, and you see that it's exactly what you will see in an exam. So first thing, when you are given the question, read the question very well. This one is saying rewrite as a single log. When we go down, it will tell you evaluate. Sometimes it will tell you simplify. So this one it says rewrite to a single log. It means that when I'm done, I should just have one log function. Okay, so let's look at it. 2 log x plus 3 log y. Now, what can I do to this one? 2 log x using the power rule. Remember the power rule? 2 log x. It becomes what?
Log
X raised to the power.
the power 2.
So log x raised to the power 2. Okay, then what about 3 log y using the power rule?
Log y raised to the
Log
power.
y raised to the power 3.
Log y raised to the power 3. Great. Now we know that the first law we looked at, if you have log a plus b, it means that a is multiplying b. Here my a is x squared and my b is y cubed. So if I want to simplify this to a single log, the addition will change to multiplication of the log functions. Okay, so who can help us here? This should be what? Log what
Log
squared?
Log
X squared,
y
Y squared,
Log x
Y
squared,
cubed.
and then y cubed. Okay, so that is how to simplify this expression from 2 log to a single log function. Okay, let's try another one so that we build confidence. What will this be equal to? Log 2x base 6 minus log 3 base 6. Log 2x base 6 minus 2 log 6 log 3 base 6. Now, first of all, concentrate on this one. There's one. 2 log 3 base 6. Using the power rule, what would that give us? Using the power rule, what will this be equal to?
Log 3 squared.
Log 3 squared. Okay, so this will be log 3 squared. Okay, and then for this one, it will still remain as 2x.
2x.
Now, please, I've forgotten to plot the base, but please, all this is to base 6. Okay, so log 2x base 6, and then 3 squared base 6. Okay. Now, we have subtraction here from the rules of log. When we are subtracting, what happens to the log?
We divide.
You divide. Exactly.
We
So we are
divide.
going to divide x here, will be in the numerator. So 2x in the numerator, all divided by 3 squared. What is 3 squared?
9.
9. Thank you. 3 squared. So we can go ahead and simplify. See whether I can simplify this. Okay, so that gives you 6 time to bring all these things together. So this
Is
minus
it 3 or 3 cube?
3 squared. 3 squared. Okay, so this will be 2x here divided by 9, all to base 6. Okay, all to base 6. So that will be your final answer for something like this. Okay, let's take one more and then we will change the whole thing to a past question. Now, look at 3 natural log of t minus natural log of 4 plus 2 natural log of 5. Now, let's look at the first one, 3 natural log of t. Power rule, what would that give us?
T squared.
T raised to the power 3, isn't it? T
Yeah.
raised to the power 3. Okay. And then this one, 2 natural log of 5. 2 natural log of 5. What would that change to?
5 raised to the power 2.
5 raised to the power 2. I hope you realize that I was rearranging the thing. I brought the addition, the 3t, and then the 2 lane 5. I brought them together because I know the addition means multiplication. And then the subtraction will be the last now, right? Natural log of 4. Okay, so now we are going to use the addition rule. Addition rule says that if the log squared, it gave me 25. So I've written that. So t raised to the power 3. Okay, all this divided by the number 4. Okay, you use the summation and the division rule to finish the proof. Okay, there are more questions here. Maybe let's try one. Fanny, what's your question?
Sir, please, can you go over the number 3 again?
Yes,
Okay.
please.
was
The line was
breaking.
breaking.
Your line is breaking.
Can you please go over the number 3 again?
I don't know whether it will be better. Give me a minute. Let me see whether if I change to Vodafone. Okay, so I'm going over, I hope you can hear me. I'm going over the question 3. Okay, so first of all, we change the question using the power rule. So I took my time and changed natural log of 3 natural log of t, it became t raised to the power 3. And then 2 natural log of 5, it became natural log of 5 squared. Okay, and then I subtracted the natural log of 4. So I use power rule to be able to get to this stage. Now then I took the first 2. You remember that these first 2 are being added. And if they are being added, it means we must multiply them. So t raised to the power 3 times 5 squared. T raised to the power 3 times 5 squared. Now 5 squared will give you 25. Okay, that gave me the 25 here. And then the t raised to the power 3 multiplies it. So it means that this is 25 times, we don't bring the times t raised to the power 3. Okay, that is addition rule. And then the division rule says that if you are subtraction, what you are subtracting from goes in the denominator. So that gave me the number 4 in the denominator. Okay, so that is how I was able to simplify this. Another handout. Alfred, what's your question?
Hello, sir.
Yes, please.
Sir, please, the final answer, 25 times t cubed over 4. Otherwise, is it the same as t3 25 over 4? Is it correct?
Yes, it is correct, but in algebra, we write the number before the variable.
Okay.
Yes, multiplication is commutative. So 25t cubed is the same as t cubed times 25. But in algebra, we normally write the number first before the variable if it's multiplying.
Okay, thank you.
Welcome. Okay, so I think we should take one more and then let's try this. This is a little bit more. Then we now will take an example where we will now expand. Okay, so who can help us with the power rule for this one? Power rule for this one. Half log x, what will it become?
A square root of
Square
x.
root of x.
Square root of x, or x raised to the power half, isn't it?
Yes, yes.
Whichever one you want. And then please, you realize that I like to combine the positive things first. So 3 log of z, what would that become?
Z to the power 3.
Z to the
The power 3.
Okay. And then the subtraction, 2 log of 2y. 2 log of 2y, what would that be?
Log 2y
Log 2y raised to the power 2.
Okay, so it means that I have to put this into brackets. 2y all raised to the power 2. Because when we expand, the 2 will affect the value 2, and the 2 also affect the value y. I hope you see that. Or else you should have written it as 4y squared immediately. But we want to take that step by step. Okay, now we are combining x squared to z cubed. Remember, they are adding. Okay, they are being added. So it becomes multiplication. So what should this log be equal to? Log what times what?
The square root of x.
The square root of x times
Z
to the power 3.
Z cubed. Yes.
So z raised to the power 3. Great. Now all divided by what? What is 2 squared? What is 2 squared?
4.
That should give you 4. And then you have what? Y raised to the power 2. Okay? Y raised to the power 2. So this is what our final answer will look like. Okay, now, so we combine into a single log. Now, what if they give you a single log and they're asking you to expand? So look at this number 6. Number 6, what will this be equal to? What do you see between the number 4? What do you see between the number 4x? What operation is between them?
Subtraction.
No,
A
4
minus.
is no, it's not mine.
Division.
No, the one in the numerator, I mean. What operation is between 4x?
4 plus x.
Addition.
Okay, so it
It
should be.
is a
So if it is multiplication, it goes with what? Addition, isn't it?
addition. Yes.
So who can help us? The numerator will be what? Log what? Log what? Log 4 plus
4
log what?
plus
Log
x.
x minus log y.
Log y.
Okay, so log 4
Log
plus log
x.
x. And then the division, the subtraction becomes division. So minus
Yes.
log y.
Y.
Okay, so you see, it is that simple if you're able to tell. Okay, so the numerator is 4 times x. So it becomes 4 plus log x. And then the division gives you minus log y. Let's take another one. What about this? Natural log of 6 divided by square root of y.
Natural log of
6
Natural log of 6
minus
natural log
minus natural log of square root of y. Now, if we change square root of y to raise the power half,
Yes.
raise the power half. Do you remember?
Yes.
Square root of y is the same as raise the power half. If we do that, then we use power rule to let the half come to multiply. I don't know whether you are seeing what I mean. So this can be natural log of 6 minus,
1 over
instead of,
2.
it becomes 1 divided by 2, then natural log of y.
Y.
Because square root of y is raised to the power half, and the half comes to multiply the function. Okay? Okay, so I think we've seen maybe one more. Let's try this one more before we take apart. This one will be long. Let's look at it and tell me. What is between 10 and x? What number is between 10 and x?
addition.
Addition.
Is addition. Okay, now if you cube root of z, change it to indices, it will be what? Cube root of z.
Z raised to the power 1 over 3.
Z raised to the power 1 over 3.
Okay, so z raised to the power 1 over 3. Okay, so the numerator, 10x becomes log what plus log what?
log 4 log 10 to base 4
10 base 4, okay, plus log what?
Log x to base 4.
Log
X
x
base 4.
base 4.
Okay, then minus what?
Log 4.
Log 4 square root of
Okay,
z 1 over 3.
Log
okay,
z
so
square root.
okay, so it's actually, I shouldn't bring square root. This thing shouldn't be square root. This should be z raised to the power
1 over 3.
1 over
3.
Base
Thank
4.
you. Base 4.
1
Okay, now let's use the power rule to simplify the last one. Let's use the power rule. Sorry, 4.
Base 4. You wrote
Base 4. Okay, thank you. So the first one, log 10 base 4. Log 10 base 4 will remain the same.
Yes.
Then log x base 4 will also remain the same. Now, then the power rule, z raised to the power 1/3 will become what?
1 over 3.
1 over 3.
Log 3.
Log 4.
Log
z.
Log base 4.
Log z base 4.
Base 4.
Okay, great. Okay, so now that we can expand or we can combine, let's take questions that says evaluate, questions that says simplify. Okay, well, there is an whole information about application of this. When I began, I told you it can be used in business models. Okay, so simple interest, compound interest is one of the applications of log. I'll leave that for you to try them. But let's take a question like this. Evaluate. So this one, we must solve and get an answer. Evaluate the following. The first one says log 4 base 3 plus log 2 base 3 minus log 72 base 3. Okay. So what happens between the number 4, log 4 and log 2? What happens between them?
multiply them.
Okay. So what is 4 times 2? I hope you know what is 4 times 2.
Eight.
Okay, so if I write 80, I hope you know how I got the 8.
Yes.
Yes. And then what happens when you are subtracting? Is it not division?
Sure.
Yes.
Okay, so that gives you 72 divided 8 divided by 72. Okay. Now there's a method to use, change this into powers of 2, but I won't do that. Please, what is 8 divided by 72? I want straight away. What is 8 divided by 72? You can change them to powers of 2 and 3s and cancels, but what is 8 divided by 72?
1 over 9.
1 over 9.
Okay, so please, you know that 1 over 9 can be written as 1 over 3 squared.
Squared.
Isn't it?
Yes.
Yes.
There's a reason why I'm writing it as a base of as 3 squared, because the base is 3. So please, whatever you do to 8 over 72, it gives you 1 over 9. And we are saying that that 1 over 9 can be written as 1 over 3 squared. Now let's change 1 over 3 squared to 3 raised to the power something. What would that be? 3 raised to the power what?
-2.
-2. Thank you. So 3 raised to the power -2 base 3. From the power rule, what would this be equal to?
-2.
-2 log 3 base 3, isn't it?
Yes.
Log 3 base 3. And you know log to the same base is equal to 1. So your answer should be equal to what?
1.
-2 times 1. Okay, this will be equal to -2 times 1. And we know that -2 times 1, the answer is equal to -2. Okay, so this question says evaluate. So we should end up getting an answer like this. Okay, so it's the same rules we started with. Yeah, a question?
Yes, please.
Go ahead, please.
Okay, please, why did you skip the second step?
Okay, I skipped that because I wanted to avoid what do you call it? Expressing the numbers in terms of factors of 2. Okay, some questions will tell you that solve the problem in terms of 2. This 8 is 2 raised to the power 3. We have done that. 72 is 8 times 9, isn't it? And 8 is 2 raised to the power 3. And then this is 3 raised to the power 2. Okay, so you realize that this would have canceled this, and then we would have been left with a 1 over 3 squared. So I just jumped it. If you're able to see it like that, you can do it that way. But if your multiplication and your factors of your numbers are good, you could immediately have seen that 8 over 72 is 818972. So that would have brought you straight away here. Okay, so that is why I did that. Depends on what you see and how you approach the question. Okay, let's take another one. What about this? I'm sure this one too. We are going to use the power rule. We are going to use the addition rule. We are going to use the multiplication rule. So let's take the first one, 2 log 5. 2 log 5, what would that be equal to? Power rule.
Exponent 2 base x.
Okay, so 5 exponent 2 to base x. Okay, and then minus 3 log 2. What would that give us?
2 exponent 3.
2 exponent 3 base x. Okay, and then what about as for 4? You know it's the same as 2 squared, but you leave it like that. So 4x. Okay, now we know that addition goes with multiplication. This one will go with this one. Okay.
Yeah.
So what is 5 squared? 5 squared times 2 squared or whatever. I mean, I'm breaking this thing down further for it to look like indices. All divided by 2 raised to the power 3. Okay, all this will be x. Okay, so we know that this 2 squared will cancel the whole of 2. It will be left with 2 raised to the power 1. So in the numerator, we will be left with 5 squared. 5 squared divided by 2, isn't it?
Yes.
5 squared divided by 2 and to base x. I don't know whether we can do anything more about this. I don't think so. Maybe the final answer should be 5 squared is 25 and 2 will be just 2 here. Or some people would like to divide 25 into 2, gives you a decimal. But because the base is x, we can't solve this further. There's nothing you can do beyond this. The base is not a number that we can evaluate. Okay. Okay, so we've solved 2 very excellent questions. This will be the last one on the Excel document, and then we'll go and look at some past questions. Now, the question says that find y in terms of x. Find y in terms of x. Okay, so let's look at 3 plus log 2, log x plus y base 2, and then log x minus y base 2. What should be your approach to solving a problem like this? If you have no idea, let me know. But if you have an idea, if you are given a problem, there's a log on the left, there's a log on the right. And they said, find y in terms of x. So what should be your approach? How do you approach this? Any recommendation?
Hello.
Bernard, are you saying something?
No
Yes,
idea.
please.
No
Okay.
idea.
Okay.
Like
You group like terms. I don't know who said it, but you group like terms. Okay. What are the like terms? The log functions.
the log functions.
Yeah. So take the log to one side and leave the number without the log on one side. So that is the recommendation. So yeah, I left 3 on the left, and then remember the right hand side is log 2x minus 2y. So here I have x minus 2y all to the base of 2. Okay. And then on the right hand side, when I bring log x plus y, when I can bring it to the right hand side, it becomes minus. Okay, it's plus on the left. So when it comes to the right, it becomes log x plus y minus log x plus y all base 2. Okay, now what do we do when logs are subtracting? Do you remember? What do we do when logs are subtracting?
We divide.
They divide. Okay, so it means the numerator here becomes x minus 2y divided by the denominator x plus y. Okay, all to base 2. At this stage, how do I get rid of the log? I don't want to see log again. How do I get rid of? At this stage, a lot of people, they get a little bit, they don't know what to do. Do you remember the from changing from log to exponent? Do you remember the rule?
Yes.
So we said that when you have log a base b is equal to c, then a will be equal to the base b raised to the power c. Okay? So I'm talking about this rule, first rule that we used. This rule. Okay, so on the right-hand side, we have x minus 2y divided by x plus y. That would be our x here, this x you have here. And then our base is the number 2. And then our answer is the number y. Okay, so my x is the fraction, the base is the number 2, and the answer is the answer equal to 3. So the formula says that let the number x be equal to the base a raised to the power y. So that is what we are going to use to solve this. Okay, so it means that here, this expression you have here stands for x. This whole expression, the one in the bracket, stands for x. So that should be my my x. So I have x minus 2y divided by x plus y. Now, should be equal to the base. My base here is 2. Remember, my base is 2. All raised to the power the answer, which is 3. So if you are able to do this, then your work becomes a bit easy. 2 raised to the power 3 is 8. 3 raised to the power 3 is 8. So now, if we have something like this, x minus 2y divided by x plus y, if you expand, what will this give you? If you expand, what will this give you? Is it not x
minus 2
y
2y equals
equal
8x
to 8x plus
plus
8y.
8y.
Okay, so if we group like terms, okay, if we take all the y's to the right and all x to the left, so x minus 8x should be equal to 8y plus 2y. Okay,
Yes.
so that final answer should give you minus 7x
7x
is equal to
9, 10
is it
y.
10y?
10
Okay,
y.
so if you make y the subject, what will this be equal to? Y will be equal to negative 7
7
X.
divided by
7x all divided by, is it not 10?
10.
Okay, so that should be your final answer. They said leave y in terms of x. So your final answer should look something like this. Okay. So basically, these are the questions or types of questions we can have be asked to deal with. So I'm going to finish up with your past questions. We'll just take a cursory look at the past questions, and then you will realize that whatever we've done today, if you choose to solve a question on logarithms, then you are in good hands. Okay, so this is distance learning last year, May, June 2025. A hand is up. I don't know the name, but it's in Chinese. Is it Chinese?
Okay. So where did you get the 8x plus 8y?
Yeah, I want to go over there.
Yes, please.
Okay, that's it.
The x minus 2y equals the 8x minus 2y. Where did you get the 8x minus 2 plus 8y?
You cross multiply. You see this denominator, the denominator we have here, it's cross multiplied, or I multiply both sides by x plus y. Okay, so if I multiply this left-hand side by x plus y, the denominator goes away. Then the x plus y goes to the right to come and multiply. I hope you see it. So
Yeah.
that is what gave me the 8x and the 8y. Then I simplify this, and it's giving me y is equal to minus 7 over 10, all this times x. Whichever way you see this.
Your line went down. Can you go over the same place again? Get the
So
8x and the 8y.
Okay, so the thing is coming from here. Maybe I should have expanded this for you to see. Okay, so if you cross multiply this equation, okay, you cross multiply this equation, you are going to have, so in the numerator, I'm going to have, if I multiply through the numerator by, let me write like this. I multiply here by x plus y. X plus y. And the numerator already happens to be x minus 2y. So the left-hand side, I'm multiplying the numerator and the denominator by x plus y. Then on the right-hand side, I do the same thing. Okay, I'm going to multiply 8 times this x plus y. Okay, so this term you have here, this particular term you have here, okay, is going to cancel the term in the denominator here. It cancels the term in the denominator. So when they cancel, the left-hand side becomes 8 minus y, which gives me the term I have here. And then this 8 times x plus y will give me the term I have here. Okay. So I expanded it and I was left with x minus 2y, then 8x times 8y. Then I grouped like terms. I took y to the right and took x to the left. And finally, I got this. Okay. Okay, so now let's see the type of questions that your seniors dealt with last year. Like I said, you will get them in the MCQs. 2 questions will come in the MCQs, and then 1 question in the session B. So this is a question in the MCQ. Now the first one says that find the values of P, Q, and R. Okay, so find the values of P, Q, and R. So 64 is equal to 8P. Can somebody help us? What can we do to 64 so that it has a base of 8? What is 64 in base 8?
8 raised to the power 2.
8 raised to the power 2. Thank you. Or square root of 64. So square root of 64 will give you 8 squared. Okay, so it means that P is equal to what? Is it not 2? If 8 squared is equal to 8P, then P is equal to 2. Okay, so we know what P is. Now let's come to this one. 1 over 64 is, how do we write it in terms of 8? 8 raised to the power what?
Minus 2.
Minus 2. Okay, so what is Q? What is Q?
Minus 2.
Minus 2. So P is 2, Q is minus 2. Now what about square root of 8? How do we write it as a power? What's the square root of 8?
8 raised to the power half.
8 raised to the power half. Okay, so we know that this is 2, this is minus 2, and this is half. Okay? 2 minus 2 and half. So that should be your answer, your C. Okay, then the question 6. It says, given that if 2 log 6 minus 3 log A is equal to log x base A, find x. Okay, so based on what we've learned so far, if we change this thing to power rule, what would this be equal to? 2 log 6 will give you what?
6 squared.
That is 6 squared. And 6 squared is what?
36.
36. Okay. Now, so 36, and when we have subtraction, is it not division?
Yes.
Okay, so what is 36 divided by 3?
12.
That's 12.
12. So now on the left, we have log 12 base A is equal to log x base A. So what is the value of x?
12.
12.
Okay. So you easily have been able to solve the MCQs without even writing or using a calculator. Okay. So that is session A. Now let's come to session B. Session B, this was the question that you were given. Again, look at this carefully. Maybe I have to copy this and send it to the Excel so that we do that. So let me copy it. It says, let me take all the questions here and bring it to the Excel document. Okay, so if I place this here, okay, this is the question. The question says that we have 9 raised to the power x minus 1, and we want to solve for x. I want to try and write the equation here. So I have 9. Don't know whether this is 9 raised to the power x minus 1, and all this being equal to, I need a bracket. Give me a minute. Let me pull a bracket. Okay, so a bracket all raised to the power 1 over 3, 1 divided by 3, and also this one to all raised to the power 4x minus 1. Okay, so how do we solve this? Okay, so Who can recommend how we go about this? What can we do to the left-hand side so that it looks the same as the right-hand side? Then we can equate the powers.
Yeah, hello,
So,
sir.
so the left hand side will be 3 raised to the power
Uh,
minus 1, close bracket 4x minus 1.
3 raised to the power again. 3 raised to the power what?
Minus 1.
Is it minus 1? No.
No,
What is
2.
9? What is
Okay,
9?
3
so
squared.
Raise to the
3
power
raised to the power 3.
2x
3 raised to the power
minus
2.
2.
yeah.
Okay, so all raised to the power x minus 1.
Minus 1.
Is it not? Okay. And then the right-hand side, how do we write 1/3 in the base of 3? It will be 3
3
raised to
raised
the power.
to the power negative 1.
Negative 1.
So 3 raised to the power negative 1, all times the 4x minus 1. Okay. Now the bases are the same. Okay. The bases are the same. So all we need to do is to equate the powers. We are here. Okay. The bases are the same. So we can equate the powers. And so this should give us
2 brackets.
So I won't be able to write English in the equation editor. So if I write 2 into bracket x minus 1, I hope you understand what I'm doing there, because the bases are the same. And then the numerator for the right is minus into bracket 4x minus 1. Okay.
Plus 1.
So now if we are asked to solve this, let's expand. What do we get?
2x minus 2.
X minus
Sir,
2.
sir,
Yes, yes, please.
if you are multiplying 2 by minus 1, then that one should be a positive one.
No, he didn't multiply through.
Okay.
Let's expand while we do that. So on the right, on the left, we are going to get 2x minus 1, isn't it?
Minus 2. Or
2x minus 2x minus 2.
yes.
Yes.
Okay, so 2x minus 2. And then on the right, what do we get? We get negative 4x.
Minus 4x
Plus 1.
1.
Great. So let's group like terms. So if we bring minus 4x to the left, so it gives you 2x plus 4x.
Plus 4x.
Plus 4x equal
Exactly.
to
And then you
1
take
minus 2 plus 1.
plus 2.
That is 1 plus 2, isn't it? Okay,
Yes.
so we end up getting what? 6x.
6x
equals
equals to
3. Is equal to 3.
Therefore, x is equal to what?
Half.
Is it not half?
Yes.
Yes.
X will be equal to 1 divided by 2.
2.
Okay, so that is how you solve a question like this. Okay, we change the bases to the same base, and from there we are able to compare, or we can equate the powers, and equating the powers, we are able to solve for x. Okay, now I hope the question, the second part, the B, everybody can do it. First, change square root of 5, x5 to powers of x. And then the fifth root of y2 also to indices. Okay? Or you want us to do it?
yes.
Let's do it.
Okay, let's see. It means I have to take my time to write. So here, we have a square root of, pick the function. I'm saying that you have to change this expression you have here into powers of indices. Oh, yeah, I knew this will happen. Okay, so I have to start all over again. So log of a divided by b. Now the numerator, we have square root of x raised to the power 5. So x raised to the power 5, I'm saying that if you have x raised to the power 5, okay, or square roots. So it means that this would also be raised to the power 1 over 2, isn't it?
Yes.
All this
Yeah.
will be raised to the power 1 over 2. And you know 1 over 2 times 5 will give you 5 over 2.
Yes, please.
I don't know whether you see it. 1 over
Yes,
2
please.
times 5
Sir,
will give
sir,
you...
we can't see what you are doing now.
It's not showing your screen.
It's showing.
Check your. I use the phone. So all I'm saying is that this thing you have here, this term you have here, can be written as all raised to the power 1 over 2. So this thing, if you don't take your time to do, so this was 5. This was 5. All this times 1 times 2. Okay, so this is what you should have. If you change this square root of x raised to the power half into indices. Now the denominator, we have y squared. So remember, we have y all raised to the power 2. And then you must raise all this also to the power 1 over 5. Okay, raise all this to the power 1 over 5. So I'm going to raise all this to the power 1 divided by 5. Okay, this one came out well. It came out well. So typing equation in that equation editor takes time. Okay, 1 over 5. Now, so if I expand this term, all this to base, we don't need a base. If I expand this, what should the numerator become? It will be x raised to the power what?
5 over 2.
5 over 2. Good. So I'm going to have x raised to the power 5 over 2. The numerator a divided by b. So I'm saying that this will be x all raised to the power here 5 over 2, like this. And the denominator becomes y raised to the power what?
2 over 5.
2 over 5. Thank you. Exactly. So 2 divided by 5. Okay. Now, then we change this thing using the subtraction rule. When your terms dividing, what do you do to the log?
You subtract.
Isn't it? It becomes subtraction, isn't it?
Yes.
Okay. So that should give you log of the numerator minus log of the denominator. Okay. Control Z. Okay. So, and then we effect the power rule. The power goes to multiply.
This month.
Okay. So 5 over 2 comes to multiply the numerator. So that gives you log x raised to the power 5 over 2 becomes 5 over 2 minus, then the 2 over 5.
It's not every matter. We need to go there and check the system.
2 over 5 here.
Because at first they were browsing it in their rooms.
You have
now
log.
the thing is not reaching their rooms.
Somebody is having a conversation. So 2 over 5, then log of y. Log of y. And then you see that you are done. So that will give you log y. Okay, so this question here, x raised to the power 5, square roots, divided by y raised to the power 2, fifth root. That will be your final answer. Okay? That will be your final answer to the problem. 5 over 2 log x minus 2 over 5 log y. Okay, we have just a few minutes. So let's take the last question. What would be log 24?
Can we do this again?
Okay. Okay.
Yes, sir, please, just
yes, please, let's go over it again because I'm lost.
Okay, so first of all, you must take your time and change the indices or the exponential terms or the square root terms into indices terms. Okay, so the first thing we did was to change x5. Maybe what you should do is do a little bit of arithmetic. And when I say arithmetic, let me put it here. If we are able to do that here, first we have square root of x raised to the power 5. Okay, so let me write that here. We have x raised to the power, where's my raised to the power? X raised to the power 5. All this was supposed to be square roots. There's a square root underneath this. We even do. Okay, so this was x raised to the power 5. Okay, now how do we simplify this? How do we simplify x raised to the power 5? Okay, now this is supposed to give me into brackets x all raised to the power 5. This is raised to the power 5. And then all this also raised to the power
1 over
2. This is what you should be able to see. If you're able to see this, then your work is a bit done. So it's x raised to the power 5. I could have put the bracket around here. It won't even allow me to put the bracket around there. But if the bracket is around this x raised to the power 5, then all raised to the power half. Okay, all raised to the power half. And x raised to the power 5 times, it means that you're saying what is 5 times 1 over 2? What is 5 times 1 over 2? Is it not 5 over 2?
Yes.
5 over 2.
Exactly. So that is the first thing you should be able to do. So this became for x raised to the power 5 over 2. And then you do the same thing with the denominator. The denominator was y, 5th root of y. 5th root of y. So you also will express that you have y here. Unless we also want to work.
Okay.
We have to use the correct term or its own pick. So this is 5th root of y. So this is what we should pick. We have 5 here, and then we have y squared here. Y raised to the power 2. So again, if you change it to indices, what should this be equal to? Is it not y squared? Y all raised to the power 2. First of all, before all this term you see here, raised to the power 1 over 5.
Yes.
Okay. If I do it this way, the equation editor will not allow me to change it to so it won't allow me to. I wanted it to write it as a fraction, but it won't. So all this raised to the power 1 over 5. Okay, so 2 times 1 over 5, like we did here. What is 2 times 1 over 5? Is it not that becomes 2 over 5?
Yes.
Okay, so this gives you y raised to the power 2 here, and this one becomes 5. So this is in the numerator, and that is in the denominator. That is what I have here. This is in the numerator, and that is in the denominator. If you're able to do this, the rest becomes addition and subtraction rule. Because it is dividing, it becomes the numerator 1 minus the denominator 1.
Okay, understood.
And you use the power rule to do it.
Sure.
Okay. My time is fast spent, but the last question, what is log 2.4? When they give you what is log, the question says, what is log 2.4? Any ideas if they give you a problem like this, how are you going to approach it? What is 2.4 in terms of fraction? Change 2.4 to a fraction. What would that be?
24 over 10.
24 over 10. Thank you. So that will give you log 24 like this, all divided by log 10. 1, 0. Get rid of these things here. And then according to the subtraction rule, because it's dividing, this gives you log 24. It gives you log 24 minus log 10. So this log 24, and then subtraction will give you minus log 10. Okay, so when you're able to write it like that, you then might find out what is log 24 in terms of factors. Please read the question again. The question says that express 2.4 using log 2 and log 3. So here, I know what is log 10. When we're doing it, I told you what log 10 is. What is log 10? 1. It's 1. So now you only have to concentrate on log 24. Give me two numbers. When you multiply, it will give you 24.
2 times 12.
Like that, but give me something that has factors of 2 and factors of 3. Even though
6 and 4.
Oh, use 8. Use 8 for me. What is
8 and 3.
8 and 3.
8 times 3. Okay, so if I write 8 times 3, you know times means that I am supposed to multiplication goes with addition, isn't it?
Addition, yes.
Okay, so I'm going to write this as log 8 plus log 3. But you know that log 8 will be 2 raised to the power 3. You understand? Log 8 is 2 raised to the power 3. So that is all I'm going to do here, and the rest, you see that the answers will come. So this should be equal to, I hope you know why I got 1. This log 10. Log 10 is 1. Okay, so I have log 8. And I'm saying for time's sake, I can write this as 2 raised to the power 3. That's 8. All this plus log 3. All this plus log 3. Log 3. Okay? And then the last one is minus 1. Okay, so here, this thing you have here, log 2 raised to the power 3 becomes 3 log 2.
Yes.
Do you see it that way? It becomes 3 log 2. So that gives you 3 log 2, and then plus log 3 minus 1. Then the rest, exactly, the rest becomes, because they say, so this 3 log 2, then 3 log 2 plus log 3
minus 1.
Plus log 3 minus 1. Then you finish up with the calculator. Okay, so that was what they had last year. And I'm sure yours will not be too different. It will also be very similar. Then use the calculator. So use the calculator to solve this, and then you give them your answer. So these were the questions they got in session B. Okay? These were the questions they got in session B. And so if the laws of your exponential functions are very strong, and then you can be able to do these questions also easily. Okay, so thank you. This is what I have for you today. I hope it wasn't too difficult. Even if it was, please, I recommend you go through the video when it is uploaded and see how best you can be able to solve the questions. I'll share the file that I'm using. And as for the past question that I just went through, it can be found online. Okay, Eric, you have your hand up. Eric, what's your question, please?
Sir, please, I was about to ask if maybe you can give the past question a PDF form to the class leader so that he will post it in the group for us. But since you are saying it's on the elements,
Yes, it's actually on the LMS. So you go to the bottom of the LMS, you see that the question is there. And so you can download it.
Yes, sir.
Okay, so the last is your Socrative. Please, the Socrative helps. It helps if you are able to practice the questions as soon as possible. So some people have even logged in already. I don't know whether you can see the room name. I shared it earlier on. I'm going to share it again in the chat room. But the room name is Distan, DISCLERN, Jan 2026 Expo. Okay, so I'll put it again in the chat room, and then you can be able to do that. Okay. So this will take care of and the topic on log and indices. Next week, if there are no feedbacks or there are no problems from this one, we will look at matrices and how to use matrices to solve a problem. I've placed the room name in the chat room, dist_len log exponent. Okay, any questions, any comments, any recommendation? Kinsley is scoring everything. Otabil, what's your question, please?
So please, can we get the questions in the slides so that we will try our hands on them?
You mean the Excel documents I'm using?
Yes, please.
Okay, definitely. I'm going to drop it right now. I'll save it and drop it either in the chat room right now. I'll also send a copy to your reps later. So definitely, I'll do that right now.
All right.
Okay.
Thank you very much.
You're welcome. Ima, what's your question, please?
So I think my question has just been answered.
Okay, great. Okay. So that is good. I'm glad today we are getting good feedback. Michael, on another hand. Michael, what's your question?
Yes, my question is, apart from the spreadsheets, is there a way you can be solving the questions for us?
Oh, you mean online teaching?
Yes, please.
Okay. Well, this question comes up every time. Well, the answer to that is there is an app or there is a gadget, but that will cost me 10,000 plus. The school won't buy it for me, which can allow me to write on the screen, and we can do that. It's something I'm saving up to. Or if you guys have some connections with some IT companies, they can recommend one. But apart from the Excel, I can type in Word, but Word will be far slower. That is the fact on the ground. The Word document will be far slower. So I've tried that and it gives me quite a lot of work. So that is my solution now. Unfortunately, I don't have any other app right now that I can use. But if you have any recommendation or you have any app you think it can work for us, definitely I will appreciate you let me know. But basically, this is what I try to use online. Maybe we can back it up when we meet physically. But basically, for now, that is what I can afford. Okay. I've dropped the Excel document in the chat room as well. There's another hand up. I don't know whether you are still there. There were two. So if you have a question, please, you can ask that too. Okay. Okay. So God willing, next week we are going to look at using okay, the hand is up. Is Ima Sechi. Ima, what's your question?
Sir, please, is the slide already on the LMS?
What are you calling slide? The Excel document?
The Excel document, yes, sir.
Oh, no, because I'm now using it. I'll upload it later on the LMS. Yes.
Okay. All right. Thank you.
Upload the one we use today right now so that you can download it just beneath the logarithm PowerPoint. So I'll do that.
Thank you. All right. Thank you.
Okay.
So, sir, please, the secretary is open till.
Let's see. What do you think? How long should I give to you? Because you guys, sometimes
we have class after a session. There's another class. We say give us some time.
So 24 hours, 48 hours.
48 hours will be okay.
Okay, so that will be Sunday evening.
Yes, please, Sunday evening.
So okay, let's make it Monday.
I hear you. Okay, you whatever. I'll ask the class rep before I close it. Maybe that will be the best, so that we are not shortchanged. Okay, so thanks for coming. Enjoy the rest of your class, and we'll meet again next week, God willing. Bye.
Okay, welcome, sir. Welcome, sir. Thank you.